Sometimes it feels like Mars is designed to keep us away. Today's Mars is a cold, dusty desert world with an extremely thin atmosphere. Yet we now know Mars was not always like this. Now, let's embark on an astonishing journey through time to explore what Mars looked like before it lost its water, atmosphere, and magnetic field. To understand the causes of these cataclysmic planetary changes, and Mars' significance for humanity's future. Billions of years ago, Mars was a vastly different place. Imagine a planet with a blue sky, flowing rivers, and vast oceans. Scientists believe early Mars was precisely such a water-rich world. Now, let's delve into this fascinating transformation process and comprehend the various mechanisms that altered Mars. Evidence from NASA's rovers and orbiters indicates that liquid water once existed on Mars' surface. River valleys, lake beds, and minerals formed in water all point to a far wetter Mars. These features show water once flowed across Mars' surface, carving channels and filling basins. One of the largest channels, Wasteland, stretches for thousands of kilometers and reaches depths of up to 10 kilometers, far exceeding Earth's Grand Canyon. Scientists estimate Mars' oceans may have covered approximately 19% of its surface, equivalent to the area of Earth's Atlantic Ocean. Mars' northern lowlands are particularly noteworthy, as they appear to be the seabeds of ancient oceans that may have contained a body of water larger than the Arctic Ocean. Picture this: Mars' surface dotted with lakes, rivers winding through valleys, and perhaps even rainfall nourishing these waterways. This scene is supported by the discovery of water-related minerals and sedimentary structures, formations that can only occur in the presence of water. These ancient lakes may have been havens for life, similar to the primordial soup of early Earth. But how did Mars transform from a potentially habitable world into the arid, dusty desert we see in rover images today? To understand this, we need to look at Mars' magnetic field and atmosphere. A planet's magnetic field is crucial for sustaining its atmosphere. For example, Earth has a strong magnetic field that protects us from harmful solar radiation and helps stabilize the atmosphere. Mars once had a magnetic field too. Magnetic fields are generated by the movement of molten metal within a planet's core. For Earth, this is known as the geodynamo effect. The motion of liquid iron and nickel produces a magnetic field that extends into space. Mars, being smaller than Earth, once had a similar but weaker magnetic field that shielded its atmosphere from solar wind erosion. Over time, however, Mars lost its magnetic field. This likely happened because Mars' core cooled down. Being smaller than Earth, it cooled much faster. When the core solidified, it could no longer generate a magnetic field. Studies suggest Mars' magnetic field disappeared approximately 4.2 billion years ago, leaving it exposed to the bombardment of solar wind. Without magnetic field protection, Mars became vulnerable to the relentless solar wind. These particles constantly bombarded the planet, gradually stripping away its atmosphere. This process, known as atmospheric escape, lasted for millions of years, and the result was devastating. Mars' once thick atmosphere was eroded away, becoming less than 1% as dense as Earth's atmosphere today. As Mars lost its atmosphere, it could no longer retain heat. The planet cooled, and the remaining water either froze or sublimated, changing directly from ice to gas and escaping into space. Mars transformed from a warm, wet world into the cold, dry planet we see today. The average temperature on Mars' surface is now around -62 degrees C, or too cold for liquid water to exist on the surface for long periods. So, did Mars ever support life? Scientists think it's possible. Liquid water is a key ingredient for all known life. If Mars had water for an extended period, microbial life could have emerged. Early Mars' environment was similar to early Earth, and the conditions that allowed life to first appear on Earth may have applied to Mars as well. Both planets had volcanic activity, thick atmospheres, and liquid water, all essential for life. If life ever existed on Mars, it was likely simple, single-celled organisms. These microbes may have thrived in nutrient-rich water, possibly finding habitats around hydrothermal vents similar to those where life originated on early Earth. Hydrothermal vents provide heat and minerals that sustain life, making them ideal locations for the origin of life on both planets. Today, missions continue. NASA's Perseverance rover is searching for signs of ancient life. Perseverance is exploring Jezero crater, once a lake. By studying rocks and soil, scientists hope to find biosignatures, chemical or physical traces of past life. Jezero crater was chosen because its delta sediments are excellent at preserving organic molecules and potential fossils. Perseverance is also collecting samples to bring back to Earth. These samples may contain clues about Mars' past climate and habitability, and possibly even fossils of ancient microbes. The rover is equipped with advanced instruments to analyze the chemical composition of rocks and soil, searching for complex organic molecules that could be signs of past life. What is the significance of studying Mars' hydrological history? There are several reasons. It helps us learn more about the solar system's history and the factors that lead to habitable conditions. It also lays the groundwork for the search for life beyond Earth. If life could have emerged independently on Mars, it would mean life is likely widespread in the universe, possibly existing on many other planets. Understanding the similarities between Mars and Earth is also crucial. Both have polar ice caps, similar terrain, and a history of volcanic activity. By studying Mars, we can gain more insights into our own planet's history and evolution. For example, volcanic regions on Mars, such as Olympus Mons, the largest volcano in the solar system, can provide clues about early volcanic activity on Earth. The knowledge we gain from studying Mars also prepares us for future human exploration. Scientists and engineers are still developing plans to send humans to Mars. Understanding the planet's history and resources is vital for these missions. Future explorers could utilize local resources, such as extracting water from ice or growing food using Martian soil, to support long-duration missions. Perhaps one day, humans will live and work on Mars. We could use Mars resources, such as water and ice, to sustain life and create a sustainable presence. With technological advancements, this dream is gradually becoming a reality. Concepts for habitats, life support systems, and transportation are currently being developed to make human life on Mars possible. The search for life on Mars is far from over. Future missions, including those by international space agencies and private companies, aim to delve deeper into Mars' surface and explore new regions. The European Space Agency's long-delayed ExoMars rover, scheduled to launch in 2028, will drill underground on Mars to search for signs of life. Microbes may be protected from harsh surface conditions there. Technological advancements are crucial for these explorations. Innovations in robotics, artificial intelligence, and remote sensing are enhancing our ability to study Mars in unprecedented detail. These technologies allow us to analyze vast amounts of data and make discoveries that were once impossible. Studying Mars also helps us optimize the search for life beyond the solar system. Exoplanets, planets orbiting other stars, are being discovered at an astonishing rate. By understanding the conditions that make a planet habitable, we can better identify exoplanets that may harbor life. With its similarities to and differences from Earth, Mars is a natural laboratory for these studies. If we eventually discover life on Mars, or signs of past life, the implications will be profound. It will challenge our understanding of the uniqueness of life and prompt us to reconsider our place in the universe. If life could have emerged onto neighboring planets, it may be a universal phenomenon, meaning the universe is teeming with life. The many missions to explore Mars have been long and challenging. Early missions in the 1960s and 1970, such as NASA's Mariner and Viking programs, laid the foundation for our current understanding. Mars rovers like Spirit, Opportunity, Curiosity, and Perseverance have built on this legacy, each mission bringing new insights and discoveries. Looking to the future, the prospects for Mars exploration are bright. Collaborative efforts between space agencies, private companies, and international partners are expanding our capabilities. The Artemis program aims to send humans back to the Moon, establish a lunar base, and use it as a stepping stone for future Mars missions. If we look even further, Mars is not just a destination, it is a gateway. The technologies and strategies developed for Mars exploration will also help us explore other destinations, such as the moons of Jupiter and Saturn. These moons may also have subsurface oceans and potential for life. When we look up at the night sky and see the bright red planet Mars, we now know this distant world may once have had conditions suitable for life. Our journey to unlock its secrets has only just begun. As we continue to explore the red planet, we will discover more of the universe's mysteries.